I'll just take 2 minutes to read the first 3 paragraphs here. Now, plate heat exchangers, okay, this is important because I would say in 90% of your applications now, anything that's replaced now, well, we shall do heat exchangers, we plate frame heat exchangers now. And there's a number of reasons for that. First is cost. Secondly is, just to give you an example of a plate and frame heat exchanger, I've seen shell and tubes that are, I don't know, say 2.5 or 3 feet across by 10 feet long, be replaced with a plate and frame heat exchanger that is this tall and this wide. Okay? You get that much more heat transfer, and I'll get into that in a minute. So get used to these. They're a little bit of some maintenance things you got to know as well. So just read the first 2 paragraphs there, and then I'll take it up from there. But these are, I would say, the industry norm now for anything that's not specialized. Any application, of course, there's going to be specialized applications where you're going to use special materials, but in most cases, the plate and frame has taken over that industry.
Morning, sir.
Morning.
Any marks on the test there?
Yeah, I'll put the marks on when I get a chance to go put them on this afternoon here. I think yours is in the low 90s. What's that?
I didn't hear what you said.
Oh, low 90s, I think.
All right. Morning, Doug.
Morning.
Are you good?
I'm sick of the dog, to tell you the truth. So don't let me breathe. I won't breathe on you. Trust me.
Shut your.
No, it's stupid. I don't know. Like a fish ray. So just read these first 3 paragraphs here. Okay. So all I'm going to do is finish. We did the reboiler section, and then I'm going to do this, and then we're done. So, this section. And the test tomorrow, or the final test, I've dropped 1 question. It'll be 6 questions instead of 7.
Laura talking to you.
Okay.
So, Jeff, we need to do one more thing first.
No way.
Thanks. All right. Kind of need it to be more narrow. Like in terms of question. But I think it's good.
There'll be 1 question on the plot. There'll be 1 question on reboiler and 1 question on plate frame heat exchange. And then the rest of it's all on the same stuff, the same questions over again.
I'm only at competition.
Everything that we've done from the beginning, there'll be a question from each side as well. No. So you're still gonna have choice. There'll be either 6 questions. I don't know. I haven't decided which ones I'm gonna put on yet, but there'll be questions that you've done before, just with I might change a word or 2 in them. That's all. But there will not be there will be none that will be. There'll be no true and false. So they're all going to be the same thing. Okay. So yeah, just read the first 3 paragraphs. Like I said, plate frame heat exchangers are the norm now for a number of reasons. frame heat exchanger are the norm now is because of the heat transfer and the foot. Everything now is down to what we call footprint. Okay, how big is the equipment?
That is one way to put many things together.
Yes, that's
I
right.
have put up on one side and
Yes, that's plate frame heat exchanger. Like I said, most of the time now you can replace a shell tube heat exchanger that weighs, could be 10 feet long and 3 feet across, and you can replace it with a plate frame heat exchanger that is this tall and this wide. Anybody? Well, why?
but they have this non-standard.
Yes, but the original problem with these, when we first started using these, the problem that we had was with the gasketing. Because what you have here is many, many plates that are counterflow, okay, and the plates are this thin, but they're all packed together on basically these four pins, and then you tighten them all down. We'll see that in a second. All these plates are numbered, 1 through 100, 1 through 200, 1 through 500, whatever it is, okay? So the reason that these provide much more heat transfer, okay, is because remember when I was talking about lamellar and turbulent flow? Lamellar flow is like it's like the wind in the meadow type flow, but you don't want heat transfer. You want turbulence. Okay? Well, these are all counterflow. The plates are this far apart. They're herringbone. Okay, so they kind of look what we call herringbone or whatever. So they have a bunch of ridges in them. They kind of look like this. Okay? So that the flow, okay, and the plates actually look like this. So you have all these ridges in there, and you have all these spots, and you have very little space in between, so you get a huge amount of heat transfer because the entire plate is being utilized on both sides. So on one side will be the media that you're trying to heat or cool or whatever, and on the other side will be the media that you're using. Okay? So you get much, much more efficient heat transfer. Now, originally, the problem that we had is with the gasketing that seals these plates from one another. If you get a leak, it's the same as you get a leak from the hot side to the the media side to the process side. But with new materials now and new chemical engineering, basically these things were only good originally up to steam of 15 pounds. That was even 10 years ago. You couldn't use them anything but. Now, you can use them up thousands of degrees, but very, very hot and very, very cold temperatures. Now, as you remember, everybody remember the Challenger disaster? See? The Challenger disaster, the space shuttle that blew up? In 86. Okay? In 1986. Okay? The thing that caused that accident was one flipping rubber O-ring. One O-ring, that big around. Okay? And the day that launch went up, it was minus 40. Okay? It was subjected to minus 40. That rubber O-ring was not designed to that, and it shrunk too much. That's what created the leak. Okay? And that's what you saw, the flame starting out like that, and that was the liquid oxygen, basically the fuel leaking, and that's, boom, one O-ring caused that. Because the material wasn't meant for minus 40, it shrunk too much. Okay? But now, with the advancements that we have in material technology, we can use these and a lot of other things for very, very cold and very, very hot temperatures.
I put on one of those twice, and the problem was the crap on the gasket.
Yes, the gasket usually always is the problem. Now, yeah, and there's a number of other things as well, but most of it.
Sometimes only one gasket because we use it to sterilize milk.
Yeah, that's one of the commonest things is sterilization,
Yeah.
right?
And
But okay, when you after you take one of these apart 2 or 3 times, you get down to science. But the other thing is that people have a tendency to mix the plates up. You mix one plate up, you're code. They're all numbered. They got to go the right way. And the gaskets go the right way. And then it's got to be torqued. So the right torque sequence to hold the bolts down. We'll see that in a second. And that's important. And then what a lot of people forget to do, especially if it's on say a steam to water heat exchanger or pasteurization one, is after it's been used for the first time, after it's been down, you have to go back and re-torque the bolts again because it'll expand. And then they loosen up again, you have to retighten them. That's usually what happens. Okay.
Usually we have a measurement for the amount that we use.
Pardon me?
We have a part length.
Yes.
For the amount of use.
Yes. There's Alpha Laval is the company that actually, I would say they pioneered this. But yeah, they've got it. It's now the company. It's now the norm in the industry. Is to use plate spray versus shells, just because of the sheer cost and the amount of heat transfer you get for a smaller unit. When I was with Spirax, we were replacing in all the hospitals. Used to have big, huge hot water tanks with a 2-ton limit. Big, huge tanks for the hot water system in the hospital. Well, we would replace these giant, inefficient units with a little heat exchanger system with a control package that was this big. So something, and that's the way things have gone now. Is real estate is very, very expensive, so there's no room for these big pieces of equipment anymore. If you look at buildings and hospitals and everything else, they cram everything up onto one floor. Okay? So you can get away with that with these. Okay. So I can just read through this a few points. Okay, the fluid flow between alternate plates. The flow direction depends upon the opening of the circumferential gasketing. Okay, the gasket around the outside of the plate to the inlet and outlet port. Okay. I hate that word, but the round oval type gaskets, okay, surround the inlet and outlet ports. The gaskets prevent the mixing with the exchanger fluid. That is the biggest thing. O-ring goes, we get a leak. Okay. The plates, the nominal gaps are 2 to 5 millimeters. Very, very thin. Okay. So you can get a lot of heat transfer using basically small plates. The other thing that we have the ability to do too is you essentially can use the same frame size and you can add and subtract more plates as the load increases or decreases, which is done quite a bit. There. They actually look like physically. Okay, so just take a second and have a look at that. Now, a lot of times now, the frames, there's not, the individual frames, a lot of times there's actually 4 bolts. But this one has 2. So bolts go from, okay, it'll be 1, 2, 3, 4 bolts. Okay, those are all the plates. There's a backing, what we call the backing plate or the front plate. So basically you get 2 pieces of plate steel, okay, on either end. This will be stationary. This slides on like this and the whole thing gets squished up into one compact unit. The bolts hold all together and then you torque the bolts down in a proper sequence. Plates, okay, brush plates have corrugations that provide the turbulence and surface area for the heat transfer. Ports, inlet and outlet ports for the fluids. Gaskets, seal the plates to provide backup for leakage protection between the plates themselves. The end plates, these are the pressure plates, do not contact fluid but provide pressure to seal the gaskets. Okay, they switch it around switch it up like an accordion. Compression bolts, used to tighten the end plates to provide the pressure to seal the gaskets. Okay, and the carrying bars maintain the plates in the upright position. So basically, when you're taking these apart and come back together. You got to put new gaskets on them, which can be a bit of a pain. Put them together and you just keep sliding the plates on, one after another after another. Put the end plate on, the tie bolts are on there, and then you start a torque sequence to take them all up. There you go. The gaskets. So that's what they actually look like apart, and the gaskets seal like that. Okay, so each one will, there's a good size one, there's a guy standing there. You see some of these, I don't know if there's any in the shop here, but I'm sure you've seen them in plants or places like Toyota. I've seen them this wide and 7 foot tall with hundreds and hundreds of plates. They cost anywhere from a couple thousand to stainless ones, $300,000 or $400,000 one used. But as you can see here, okay, with all the ridges and the openings, okay, is that you're going to get turbulent flow. You're going to get heat transfer. Okay? Because there's no place for air, there's no place for anything other than heat transfer to take place. And between each plate, you get counterflow. Usually it's counterflow. So as your heat transfer is going down, your medium to be heated is coming up the other way. Sometimes they actually flow the same direction, but most times they're opposite flow. Okay. So you can see the flow through each, and then have any of you ever worked on these? Did anybody else work on it? You will. Now, there's a lot of instances now, okay, instead of these plate packs and gasketing, okay, for the smaller size units, a lot of the higher temperature and pressure ones, these are all welded, and they're throwaway units. So basically it comes from the factory, it's all welded together, and then you use it for umpteen years, and so you have a problem or something happens, and then you just put another one in. The amount of labor that, if you look at this, and say there's 300 plates in that, so then there's 100, the gaskets, there's 120 gaskets. Okay, it's, you only take them apart when you absolutely have to, or when it's part of the preventative maintenance program. But it's labor intensive to take it apart and put it all back together. Normally, you'll have if you have a big heat exchanger like this, it'll be still under contract from Alpha Laval or one of those big companies, and they'll come in and do this for you. Or normally what you'll do now, instead of doing this, is that you'll have a plate pack what's called a spare plate pack in your stores. And this goes down, you just rip it out, it comes as one unit all sealed together, you put that in and you send this one back to the company. Okay. And that's normally what's done now. You don't actually start playing around with these because it's so finicky to do. And it's a pain in the butt, especially. It's cumbersome. But this is generally the norm in the industry now for general heat exchanger use. Okay. And the main reason, of course, being is that you get a lot of heat transfer through a unit that's very, very small versus a shell heat exchanger, which can be very, very large, very expensive. This is really embarrassing. There's 3 advantages and 3 disadvantages of plate and frame heat exchanger. Let me move that up. I'm using Yeah, this too, as a subsection of the question. Now we'll just do advantages first. Low fouling characteristics. A, due to high turbulence, few stagnant region, and low residence times. Okay, what does that mean? Low fouling characteristics due to high turbulence. What does that actually physically mean? What does number one mean? What does low fouling characteristics due to high turbulence mean? Okay, if you've got turbulent flow, it means it's fairly speedy, it's fairly violent, right? Okay, so you have high turbulence. If you've got material or if you've got heat transfer going through these plates at a fairly good velocity and it's very, very violent, what are the chances of a piece of fruit getting stuck on those plates?
Near to nothing?
Yeah, near to nothing, or it's much, much less because there is turbulent flow. So that's what that means. Okay. Few stagnant areas and low resistance times. Okay, there's few areas where there isn't. You know, there's always flow going through, so the material can't sit there and basically stagnate out or create an area where it's going to actually cook to the tubes itself. Number two is what I just described to you as far as a plate frame heat exchanger replacing a very large heat exchanger. Okay? High heat transfer coefficient producing a surface area required for a given duty. Okay? 1/3 to 1/2 of that required for a tube and shell or shell and tube heat exchanger. 1/3 to a half. I think in some cases it's actually more than that. So you can replace a big expensive unit for a very, very small unit. Leakage is detected immediately. That's a bit of a caveat. Sometimes it can be, but if you've got gas on one side or lower or higher pressure on the other, you can actually have leakage from the high pressure side to the low pressure side. You may not necessarily know right away. Be careful with that. Okay. Small footprint. That goes back to number two as well. Okay, so if you got a shell and tube heat exchanger that takes up half the room, and then this thing only takes up a little bit in the corner, less space, right? Okay, small liquid hold up. Okay, and they do require less space to dismantle them. You got to remember, if you got a tube pack that's this thick, this wide, you're going to see the basically the hold down bolts and the plates and everything. There's going to be this much room on it. It looks like the tube pack is too small for the unit itself. That's by design, so you can spread the whole thing out. Okay, you can also change the load on it. You can add plates and subtract plates. The load varies. Not very often it's done, but you can do that. Okay. Plate heat exchangers are capable of rapid startup. Okay. Because there is very, very little water volume in it, or volumetric space in between, you get instantaneous heat transfer. Whereas a big old shell tube heat exchanger, you got to basically heat the volume of the material up that's in it, get flow going, heat the material up, that type of thing. No insulation is required. Be careful with that one. Okay. You can walk by these units because you don't insulate them, basically. But you can walk by them and they're cooking. You can feel the heat coming off of them. Whereas you got a shell tube heat exchanger that's insulated, you don't feel anything. These you can't do, right? So be careful with that one. Vibration free, I wouldn't touch that. I mean, vibration free, what does that really mean? And they still do vibrate. I would say that these are more susceptible to vibration than plate framework. I mean, shell and tube rather. because you got all those plates there and those gaskets, and these things vibrate like crazy, whereas the shell and tube can vibrate quite a bit without. So I have a problem with that one. Disadvantages. They say right off the bat, gaskets. Limit application by temperature and pressure. 27 megapascals, 175 Celsius. That temperature is changed. It's higher now. Pressure and temperature are higher, but it's say not recommended for the viscous thick fluids. Of course, that's true. Low flow rates creating velocities less than 0.1 meter per second can create flow distribution. Okay. This is the big one here. Okay. Low flow rates, of course, you get a very, very low flow rate, you're not going to get good heat transfer. This is the biggest one. There's a pressure drop across these units. Okay. That's one inherent problem, is because you have very little space in between all those all those plates, you're obviously going to get pressure drop, and more so than you will in the shell tube heat exchanger. Number 6, not good for containing toxic materials. I don't know where you would actually. Okay. Okay, can only be disassembled by a certain number of times before new gaskets are required. Okay. Personally, the only ones that I've ever seen taken apart and put back together many, many times are pasteurized or heat exchangers, same gaskets. Because they are low pressure, usually low temperature. But any units that, as soon as you take them apart, you can't use the same gaskets again. You got to put new gaskets back in. So it's pretty easy to come up with 3 advantages or 3 disadvantages. They're pretty. Just go back to the general design. And that.
Just quantify vibration free.
Oh, question. What do you mean? I'll go. What do you mean by vibration free?
They said disadvantage and advantage. So quantify advantage free, vibration free.
Okay, so now I'm going to ask you if you put an advantage. You better explain to me why it's vibration free. And I don't agree with it being vibration free. Just stick to the one low balance characteristics, the high heat transfer.
What is the no insulation?
It's yeah, no.
Steel line.
No, it's no insulation. I would say that no insulation is required. You can't insulate them. How are you going to insulate a plate frame heat exchanger? Cover it over.
No, so what about the lines that come to it?
Well, the lines that go to it, of course, are going to be. Yeah, absolutely. They're going to be insulated. But that's what I mean. If you walk by, if you have the same process and you have an old shell and tube heat exchanger that's insulated, you know, you can't tell. But if you put a plate and frame in there, you can't insulate the tube pack, so that's going to be very warm on the same process. That's why I find, you know, the arguments kind of. I have seen some units they've tried to insulate, but you're just asking for trouble in my opinion. Rapid startup, you know, small footprint, you get a lot of heat transfer for small area. Those ones are pretty straightforward. Well, you know, it's very hard to have these foul because there's so much turbulent flow.
Annually, just we need to clean the place.
What's that, sorry?
Clean the place, no?
Normally what happens if prime example is, we had some of these issues with the plate and frame heat exchanger we're putting in, and especially in hospitals where the city water was really hard and we were using steam, is they would foul fairly easily. So that's why we have to use softened water and use our own water. However, instead of taking them apart to clean them, what we did is acid water in place. Isolate them, hook up, you have a portable unit, So a lot of, anybody can still use this for shell and heat machines too. To see an acid wash unit, the maintenance guys will go up and they'll isolate it, and during a shutdown, they'll acid wash the whole thing, but it takes it all apart. Any questions? Pretty straightforward stuff. Makes a good little question. And that, gentlemen, will be the be all and end all right there.
You want to do it?
Yeah, I just did that at the beginning of the class, so.
It's not sharp.
What's that?
Not short.
Yeah. That's short. There's two different types of reboilers and 3 different types of reboilers, and then it's just that short. You got it. Yep, right. Yep. There. And this is what you want to do. You want to know the difference between, that's the kettle type, okay, and then the thermal siphon type is completely flooded. That giveaway with the reboiler is that the shell tube has a bulbous body. Because what you're doing is you're taking the bottom out of the distillation tower, and you're basically reboiling it, okay, so you can send the vapor back to be taken off again. Okay, so it's all the top, like gas. Where the thermal siphon type below the level line is completely flooded. That's the difference between the two. And the other application is feed water for turbine plant. That's basically the extent of which you will be asked. Now, if you put your marks on, I've got most of them done, so I'll put them on today, or tonight anyway. So. And then I'll be in the classroom tomorrow. So I don't think there's anybody in there. I'll be there about 2:30. So, and then